In this example, we are going to find the expected value or the mean of a probability distribution. So the Top Speedway is a supplier of automotive parts. Included in stock are 5 speedometers that are correctly calibrated and 2 that are not. 3 speedometers are randomly selected without replacement. Let the random variable x represent the number that are not calibrated. So if we are randomly selecting 3 speedometers, then then we know that out of these 3 that we are selecting, that there could be 2 that I select that are not calibrated. Since x represents the number that are not calibrated, then x must equal, right, either out of these 3. So I guess let me draw it. Okay, so here are 3 that I select from the supply of automotive parts, right? And if I select 3 and only 2 are not calibrated, that means there's a chance when I go ahead into the box and I select 1, 2, and 3, that these 3 all are calibrated, right? That none of them are not calibrated. And therefore, 0 can be not calibrated. So let's say I go in now and I go ahead and I select 3 of these, but now 1 of them happens to be not calibrated. So there's another situation where 1 not calibrated, but 2 calibrated. Okay, and the next one would mean that if I select 3 speedometers, that I could select 2 that are not calibrated and 1 that is calibrated. Okay, and then the last situation would mean that if I select all 3 of these and all of them are not calibrated. So we do have a situation with 4 scenarios, right? Now, the scenario, if x equals 0, so let me put scenario 1. If x equals 0, then all are calibrated. Okay? And if x equals 1, then 1 is not calibrated and 2 are calibrated. If x equals 2, then 2 are not calibrated and 1 are calibrated. And if x equals 3, then we would say then all 3 are not calibrated and 0 are calibrated. So you can see now all the combinations. Okay, and so these are the ones that we're going to find here. So if I just color code them, you'll see the situation. Okay, so that's kind of the first part. The second part, these are all little notes we can make mentally, of course, but the second part would be kind of gathering the data they gave us, right? So they said that 5 speedometers are calibrated and 2 are not. And that means that 5 plus 2 is 7, so there's a 7 total speedometers that we could pick from. And then we're randomly selecting 3. So we are grabbing 3 out of the box, right? Here's the box, and we're going to take 3. Of those three, all of them could be calibrated, which come from the 5, or one could be calibrated, right? And then two are not calibrated, or two of them could be calibrated and one not calibrated, right? And then if I selected all three and they were all not calibrated. Okay, so I think we're ready, and there's a couple of ways we're going to do this because there's so many different ways. For example, if I went ahead and said my first pick one, right? Here's pick 1, 2, and 3, right? If my first pick is not calibrated, yes, and my second one is not calibrated and then not calibrated. But couldn't my yes be, well, my first pick would be a not calibrated and then the second calibrated and then not calibrated? Right? And then couldn't it be, well, no, no, and then yes, right? So if I have two not calibrated, this would be x equals 2, right? If x equals 2, that means that the two of them are not calibrated, right? And so that would be these two. But notice that there's different ways that you can select these, right? It's not just you're picking that one first and then the other two aren't. So because of this combinations, we would have to use a combination formula when finding probability. So the last piece we should write down, number 3, is that we're going to have to use combinations for finding the probability. And so we're going to end up finding 4 probabilities. And these 4 probabilities is the chance that I select these 3 speedometers and none of all of them are calibrated, or just 2 of them are calibrated, or 1 is not calibrated, or here 2 are going to be calibrated and 2 will be not calibrated and 1 will be, or all 3 will be not calibrated. But notice just from when x equals 2, we have these combinations of different ways we could select the 3 in which order we get the not calibrated. So because there's many ways that we could pick the 2 that are not calibrated and the 1 that are, it's important that we realize that we can use combinations. Of course, you could use the conditional probability formula, but that would take a little bit more work and we would just want to work a little smarter, not harder. Okay, and I think we're all set now. Let's go ahead and answer the questions. The first one, the probability for when x is equal to 0, that would mean, again, if we think about it over here, that they are all calibrated. And if they are all calibrated, that means I can have 5, choose 3 to pick from. I can pick 5, choose 3 that are all calibrated out of the 7 speedometers in the box that I'm picking for 3. Okay, and if I want to find the probability where x equals 1, again, this is when 1 is not calibrated and 2 are. So if 1 is not calibrated, that has to come from the 2 that are not calibrated in the box. So I have 2 and I'm choosing 1 that's not calibrated. So I have 2, choose 1, but then that means I have 2 that are calibrated out of the 5 I'm able to pick from. So if 1 is not calibrated and 2 are, then that means I have to multiply by 5, choose 2 that are calibrated. All over, well, just 7 in the box, choosing 3 speedometers. Okay, and if the probability x equals 2, this means, going back to our notes, that means that 2 are not calibrated out of the 2 I can pick from the box that are not calibrated, and 1 is calibrated out of the 5 that are calibrated in the box. So this means that if I pick 2 that are not calibrated out of the 2, then I have 2 choose 2 because I'm picking all of the not calibrated speedometers. But that leaves me with 1 that I'm picking that is calibrated out of the 5. So that means I have 5, but choose 1 that's calibrated out of the 7 in the box that I randomly choose 3. Now, for the probability that x equals 3, so I know already some of you are already thinking, like, I don't understand this last one, because if I say 3 are not calibrated, but only 2 in the box are not calibrated, it's impossible that I pick 3 that are not. Because only 2 in the box are. How do I pick 3 out of 2? That doesn't make any sense. And I would say absolutely, it is impossible. And we learned in chapter 3 that impossible means that probability is 0. So right away we can put right here on the table when x equals 3, the probability is 0. Now what we can do is go ahead and use our calculator to calculate these combination probabilities. So this is Desmos, and if you click Functions and go to Stats, then you can see the NCR down here, and you would just click it, and then you just do your choosing. So remember when x equals 0, we had all of them to be calibrated, so we're going to 5 choose 3, so 5 comma 3. Okay, divided by, going back to the function NCR, out of the 7 in the box that we're choosing 3. Okay, and so we have 2857. Great. And then let's put that in the box. And we can see on the right side that these are the correct answers so far. So we have 2 more to do. So let's do when x equals 1. So recall when x equals 1, that means go to Functions, click NCR, and that means that out of the 2 that are not calibrated, I'm picking 1 that's not calibrated, times, go back to Functions NCR, that out of the 5 that are calibrated, I'm picking 2 that are calibrated, divided by function NCR, out of the 7 in the box, randomly choosing 3. And we get 0.5714. And we'll put this in the box. Okay, the next one is when we choose all 2 non-calibrated with 1 calibrated. So let's go ahead and do that. Go ahead and go to Function NCR. This is when we have 2 not calibrated, and we actually randomly select both of them that are not. Times, go back to Functions NCR, that out of the 5, we're picking 1 that is calibrated. Divided by, go back to Functions NCR, out of the 7 in the box that you're randomly selecting 3. So this is 0.1429. And again, I'm rounding correctly, so make sure you check those test digits. Okay, so here is the probabilities for the table for the first part. So now that we have the probabilities, we can now go ahead and do the second part is finding the mean or the expected value. And so we can go ahead and do that. Let me scroll down a little bit. And so in this case, to find the expected value or the mean of the probability distribution, you would have to take each x and multiply by the probability of x for each one. So if I went ahead and did that, we would see that 0 times 0.2857 is just going to be 0, because 0 times anything is 0. 1 times 0.5714 would just be, well, 0.5714. For x equal 2, 2 times 0.1429, well, we can go ahead and put that in the calculator. 2 times 0.1429, and we get 2858. And the last one, 3 times 0, well, that's the same as above, which is 0. So the expected value, if we go down here and put number 2, finding the mean, or in other words, expected value, that's just going to be the sum of all the products that we just found. So it'll be 0 plus 0.5714 plus 0.2858 plus 0. And so when I add those up, I can go to the calculator and put 0.5714 plus 0.2858, and we get 0.8572. Great, we're almost there. One little kicker is that it says apply the appropriate rounding rules. So because the data given to us has all been in whole numbers and integers, right? They tell us 5 are calibrated, 2 are not, right? These are all discrete. Therefore, appropriate rounding rules would mean that we round to 1 decimal place past our data. In this case would be the 10th place. So here I would say the 10th place, looking at my test digit, this changes to 0.9. And then of course we can see that is the answer. Okay,